This is the definition of the parsec. Let's first define the astronomical unit. Earth follows a roughly circular orbit with a point where it's farthest from the Sun, called aphelion, and a point where it's closest to the Sun, called perihelion. Taking the average distance of Earth throughout its orbit is a useful simplification to our model. In this simplified model, one astronomical unit is the distance from Earth to the Sun. Next, let's evaluate visual parallax. Consider some stellar object with a background which can be referenced. As the observer changes positions, the closer object will appear to move with respect to its background. From the perspective of Earth at the first point in its orbit, the object appears closer to background star 1. From the perspective of Earth half an orbit later, the object appears closer to background star 2. We can find the shape of the apparent path of the object through the sky on Earth. First, we draw the sight lines from the object to Earth at both points in its orbit and to the Sun. Next, we orient ourselves so we are looking along the plane created by these sight lines. Here we see that the path that Earth appears to take through the sky from the object's perspective is elliptical. This is the same path that the object appears to follow from Earth's perspective. The scale of this path is greatly exaggerated for illustrative purposes. Adjusting our perspective so that we're looking orthogonally down on the plane of the sight lines, we can see a clear geometric picture emerging. The orbit of Earth is no longer necessarily orthogonal to anything, so we can safely ignore it. Let's trace the angle between the two sight lines. This angle theta is twice the parallax angle p. We previously established that the distance from Earth to the Sun is 1 astronomical unit. If we mark the distance from the object to the Sun with d, we can apply some simple trigonometry to find its value. Distance is 1 over tangent of parallax angle. When the parallax angle is much smaller than 1 arcsecond, we can use the small angle approximation to simplify the expression for d to d is 1 over parallax in arcseconds. We should define an arcsecond. We can measure the angle between the hands on a clock in degrees, minutes, seconds, or degrees, arc minutes, and arcseconds. If we call one complete revolution around the clock face 1 degree, then we can call the divisions of the degree minutes and seconds and apply our usual concept of time for understanding. One arc minute is 1/60th of a degree, and 1 arcsecond is 1/3600th of a degree. Let's revisit the triangular model from earlier. When the parallax angle p is 1 arcsecond, and the distance between Earth and the Sun is 1 astronomical unit, then the distance from the object to the Sun is 1 parsec. 1 parsec is approximately equal to 3.26 light years.